Hey everybody, this is Mr. Kuchenmeister. So first off, I wanted to apologize because this is probably the first time you're hearing my voice in a video this week. Upon discussion with Mrs. Turner, we found some videos that were made in the past that did the same proof, so there was no sense to make another video with just me talking. So hopefully you guys are hanging in there this week as I'm gone, but we're coming toward the end of it now, so be I'll be coming back soon. Hang in there, we'll go from there. So today we're going to be going through 3.3, but before we do that, I thought it'd be a good idea to go ahead and take a look at this question from your homework, which is proving the alternate exterior angles theorem, which, if you remember, what that states is that when you have if two parallel lines are cut by a transversal, then the two pairs of the alternate exterior angles are congruent. So our job is to prove that angle 1 and angle 2 are congruent. So we're trying to prove, if I look in here, trying to prove that this angle is congruent to this angle. So on your homework, you'll notice that I gave you no word bank, and what we need to do is we kind of got to work from there, all right? So the first thing we need to do is let's go ahead and write down our given, because I always told you in proofs that always our given should go here. So our given is line L is parallel to line M. And we can just go ahead and put given here. Okay. And I'm going to go ahead and down here and fill out this box because we know that this last box is what we need to prove, and that is angle 1 is congruent to angle 3. All right, so how are we going to get there from the first step here to the last step down here? All right, so let's go ahead and start here. So line L is parallel to line M, which means that angles 1 and 3 are congruent, is the next statement. Well, we can go ahead and say, hey, by the vertical angle theorem, angles 1 and angle 3 are congruent because we have two angles that are not adjacent formed by two intersecting lines. So I'm going to go ahead and say vertical angle theorem here, which is something we proved in chapter 2, which definitely means we can use it now. So vertical angle theorem. All right, so that's good. So we're good there. Now we need to figure out a reason for why angles 3 and angles 2 are congruent. And there's a postulate in section 3.2 that you learned. It is called the corresponding angles postulate. If you remember, the corresponding angles postulate states that two corresponding angles are congruent. So we can go ahead and say, hey, by the corresponding, I'm just going to put CORR angles, and I'm really abbreviating here, postulate, I can say angles 3 and angles 2 are congruent. Now, how do we gotta get from, well, how do we know that angles 1 is congruent to angle 3? Well, we can actually go ahead and use transitive property here, which you remember, transitive property of congruence states that, hey, if I have A is congruent to B, and then B is congruent to C, then I can say A is congruent to C. So if I took a highlighter here, we go, all right, A is congruent to B, B is congruent to C, and then I can go angle A is congruent, figure A is congruent to C. Oh, hold up. Made the wrong color, my blue. All right, so let's go ahead and see if we have that here. So we have angles 1 is congruent to angle 3, and angle 3 is congruent to angle 2. So yes, we have everything we need. All right, let's try that again. Sorry, I knew this wasn't going to go smoothly here. All right, so anyway, where was I before my smart notebook crashed? So we were talking about how this is going to be transitive property of congruence here, because I have A is congruent to B, with B is congruent to C, so that means A is congruent to C. Let's see if we have that. We have angle 1 is congruent to angle 3, and then we have angle 3 is congruent to angle C, which means I can say angle 1 is congruent to angle 2 by transitive property of congruence. So if you were stuck on that one, there's your answers. Okay. Quick reminder about proofs is that, remember, if it's a theorem we've proven, or if there's a postulate, a definition, or whatever, you can use it. So without that being said, we are going to go ahead and jump into section 3.3, your last section of the week here before I come back next week. So 3.3 is more parallel lines. We're going to do some more proofs here that are related to parallel lines. So the main goal here is using angles formed by a transversal to prove two lines are parallel. So now we're kind of going to go backwards, what you kind of already been doing here, but it will make sense as we go from here. So you'll see some proofs, you'll see some applications, and go from there. So let's begin. So some not so random reminders, okay? Just a friendly reminder, what is the converse if you have the following conditional statement? If you have 4 quarters, then you have $1. The course, then you could say, if I have $1, then I have 4 quarters, all right? So remember, the converse is flipping the hypothesis over there. And then from last class, or your last video, corresponding angles postulate says, hey, if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. All right, now think about what the converse would be of this. If the corresponding angles are congruent, then the 2 parallel lines are cut by a transversal. So that's something to take into consideration as we go into this section. All right, so your first postulate here is called the converse of the corresponding angles postulate. So this is a converse of a postulate you already learned from chapter 1. So first things first, it says, if 2 coplanar lines are cut by a transversal, then, if 2 coplanar lines are cut by a transversal so that the pair of corresponding angles are congruent, then the 2 lines are parallel. So basically what they're saying is, if you have 2 coplanar lines, right? So here's 2 coplanar lines that are cut by a transversal, so that a pair of corresponding angles are congruent. So they're talking about, if I were to circle here, they're talking about this angle and they're talking about this angle. If you were given that those 2 angles are congruent, well, then you can say that those 2 lines are parallel, all right? So that's what this is talking. It's almost the reverse. So if you remember from 3.2, you were given the opposite, that if 2 lines are parallel, then the corresponding angles are congruent. So this is a case where both your converse and original statements are true. So we'll go back from this, but make sure you get this vocab down and we'll move on. All right, so we're actually going to do a mini proof here. So given that angle 1 is congruent to angle 5, prove that line L is congruent to line M. So if we're doing this here, let's find angles 1 and 5. So angles 1 is right here. Here's angle 5. Those are definitely corresponding angles here. So what we can do is we can say, hey, well, we're given that angle 1 is congruent to angle 5. And then I'm going to say given for that. And then since this is a mini proof, you guys all know what's coming next. That means line L is parallel to line M. And we can say by the converse of the corresponding angles postulate. Okay. Well, hey, if we have 2 corresponding angles that are congruent, then we can say that these 2 lines are parallel. Because we already know from a previous section that if 2 lines are parallel, then I'm going to have corresponding angles are congruent. They work the same way. All right. So let's go ahead and take a look at this proof. Woo. Okay. So we got a lot going on here. All right. So first things first is, given that the measure of angle 4 is equal to 2x plus 10, and the measure of angle 8 is equal to 3x minus 55, and that x is equal to 65, we need to prove that line L is congruent to line M. So let's go ahead and start, what we're going to write down every single time here is given. All right, this whole box is given here. All right, our job is to prove that these 2 lines are parallel, okay? Now you might be asking, well, wait, can't I just do what I did in the last thing was? Well, not necessarily, right? So right now we have to prove that angle 4 is going to be congruent to angle 8. So thankfully, this is some algebra that we can do here. If we can get down that these 2 angles are congruent, we can get down to there. So again, notice on your notes here that the statements part of the proofs are complete. So let's talk about here what they're doing here. So in the first step, we have the measure of angle 4 is equal to 2 times 65 plus 10. And all they're simply doing there is good old substitution because, hey, I already told you that x is equal to 65, so why not plug it in here? So we got substitution there, and we're also going to have substitution right here. Something we are allowed to do because, again, it was given. I told you what it was in the first statement. All right. So now, by doing some quick simplifying here, so 2 times 65 is going to be 130. 130 plus 10 is 140. So we could say in our next step, hey, by just simplification or simplify, right? We now know that measure of angle 4 is equal to 140. And then I can say, hey, 3 times 65 is 195, and 195 minus 55 is 140. So I can also say that's simplification, right? Well, now let's think here. What do I have? Well, I have two angles that are congruent because they have the same measure, right? So down here, this is just substituting in here, and I'll show you by a highlighter how it is. Okay, so we know here's the measure of angle 4. That's going to go down right here, right? We know the measure of angle 8 right there. Okay, and I know that both of these are 140, right? So I can say, hey, I'm going to replace 140 with the measure of angle 8. And again, that is by substitution. And I think you guys know where this is going. Okay, then I could say, hey, if these two angles have the same measure, well, then they are congruent by the definition of congruence. And I apologize, but I'm being lazy here. And since now what I have is, if we go back up to the figure real quick, I had now just proved, okay, using some pretty easy steps here, I have now proved that angle 4 and angle 8 are congruent, and since those two are corresponding angles, all right, I can use the postulate I just showed you, which is the converse of the corresponding angles. Corresponding angles postulate. Okay. And a friendly reminder, okay, with postulates are statements that don't need to be proved, right? They're just statements that are generally accepted as true without proof. Okay. Now, if we go back here real quick, right? You guys already learned the opposite of this. I shouldn't say opposite, but you already learned the original corresponding angles theorem that said, hey, if I have two parallel lines cut by a transversal, then these corresponding angles are congruent, right? So the converse of this is just going backwards and saying, hey, if you're given two angles that are congruent and they're corresponding angles, then you can say the two lines are parallel. And that's only if you have a transversal that's closed there, all right? So again, I know this proof kind of looks scary, but what would have been trickier about this proof is if I didn't tell you what x is, like if I just crossed that part out. But I didn't in this case. So in this case, we were good. So it's just some simple algebra and going from there. All right, so let's go ahead and take a look at this problem here. So in this problem, I give you two lines that looks like they're cut by a transversal. I'm not told that these two lines are parallel. Okay, my job is to find the value of x that makes lines u and v parallel. Okay, so this isn't a proof, but this is the type of problem you might see on your homework. Okay, so we're looking at these two angles here. So I'll get my highlighter back out here. So if I'm looking at this angle here and I'm looking at this angle here, I know that those two angles right there are corresponding angles. Okay, and the postulate I just found out said that, hey, if I want this line and this line to be parallel, then that means these two angles have to be corresponding angles, which means they have to be congruent. So what I can do over here is, okay, I can start off with, if, I can turn this into a nifty conditional statement. If 16x minus 5 is equal to 75, then line U is parallel to line B. Okay, so that's the statement based off of that I know I can use. Okay, and if anyone asks you a reason, you can just say, converse of the corresponding angles theorem. Postulate, my apologies. So now we have a basic algebraic equation we're going to solve. So we'll add 5 to both sides first, right? Because we undo addition or subtraction before we undo multiplication. 16x equals 80. divide both sides by 16, and 80 divided by 16 is going to give us x equals 5. So that means here in this case, okay, when x equals 5, line U is parallel to line M. I'm sorry, line B. Okay, please know, all right, you need to write this whole statement out. I need to see this on your homework, okay? Because all I asked was find the value of x that makes sense, all right? So don't just give me x equals 5. I need this whole statement here, otherwise you will not get full credit, okay? You don't necessarily need to write line out. You can just write the lowercase u's. I'll know that means line U. Go from there. But that's what I need to see, all right? In order to get full credit, you must write this. So that's an example of a problem you might see on your homework, all right? So now let's talk about some other theorems here that we're going to talk about proving parallel lines here. So first one, okay? First theorem, converse of the alternate interior angles theorem. If two coplanar lines that are cut by a transversal so that the pair of alternate interior angles are congruent, then the two lines are parallel. Okay, so again, this is just this converse of the same alternate interior angles theorem that you already know from 3.2. Okay, so basically that says like, hey, if you are given two angles that are congruent and they're alternate interior angles, then you can say the lines are parallel. The converse of the alternate exterior angles theorem says the same thing. If I'm given two alternate exterior angles that are congruent, then I can say the lines are parallel. So let's go ahead and let's prove these two theorems. Oh, I'm sorry. There's one more, and then we'll get into it. And just like the theorem you learned in 3.2 about same side interior angles, then you can take the converse that, hey, if you're given two same side interior angles that are supplementary, then the two lines are parallel. So again, remember the whole point of this was these two add to 180 if you were given that the two lines are parallel. All right. So kind of want you to think along the lines of, hey, these are already theorems you've already done, but now we're doing the converse of all of these. All right. So let's prove the converse of the alternate exterior angles theorem. So in this case, okay, we're given two alternate exterior angles. One is right here, or two is right here, and we are given that those two lines are parallel, not parallel. Our job is to prove that those two lines are parallel. We are given that angles 1 and angles 2 are congruent. Okay. All right. So let's see what we got here. Next statement says angle 1 is equal to angle 3. Angle 3 is right here, and it's actually the vertical angle to angle 1. So we can go say, hey, vertical angles are congruent by the vertical angle theorem. And then again, I can kind of pull either substitution or transitive property. Now, given that the way these two statements are written, I know I've talked about this in the past, especially when we first did proofs, that, hey, technically in order for this to be transitive property, we would need one more line here. So I don't necessarily like using transitive property here. I would rather have it, this third statement be angle 3 is congruent to angle 2 to use transitive property. So what I'm just going to do is, hey, there's angle 3, right? We have angle 1 is congruent to angle 2, and then we have angle 2 is congruent to angle 3. So what I'm going to do is I'm going to substitute angle 3 with angle 2 to say those are done. So I'm going to say substitution, but please know, if you write transitive property of congruence, I'm not going to count you as wrong. And then I'll change colors here. I'll go, you can also use transprop of congruence. Either way, the theorem is now proved, since we now have angle 2 being congruent to angle 3. Those are corresponding angles. So what we can do is the postulate we just learned in the beginning, the converse of corresponding angles postulate. The trick to this section is knowing those theorems from 3.2, because if you don't know those theorems from 3.2, well, then the converse of them is going to be pretty difficult. But if you know the theorems, all three of them that we did, then the converse of them is going to be pretty simple. All right, so let's see here. Move this over here. So for both examples, find the value of x so that that makes line U and line V parallel. So again, this is kind of a simple application here. What we're doing here is we're using the converse of the alternate interior angles theorem, which states, hey, if this is equal to this, then I can say the two lines are parallel. So that would mean 19x minus 4 would have to equal 110. So let's go ahead and solve that algebraic equation. We'll add 4 to both sides. 19x equals 114. Then we divide both sides by 19. And that's going to give us x equals 6. So the statement you would need to write, when x is equal to 6, line U is parallel to line V. Nice thing, this isn't a proof, so we don't need to justify our steps. You can just say, hey, I'm using this theorem, so I can say these two have to be equal. Okay, so in this case, now we're going to do two same side interior angles here. So the theorem we're going to be using is the converse of same side interior angles, okay, which says, hey, if this angle and this angle are supplementary, which means they would have to add to 180, then these two lines are parallel. So what that's going to look like is create an equation here. Let's go green here. So we'll go 31x plus 6 plus 13x minus 2 equals 180. And then let's solve this bad guy. So we're going to combine like terms. 31x plus 13x is going to give us 44x. 6 minus 2 is going to give us plus 4 equals 180. I don't like that. Let's keep the color organization nifty. So equals 180. Now we'll go to black and we'll solve this. Subtract 4 from each side. That's going to give us 44x is equal to 176. And then if we divide both sides by 4, we will get x equals 4. So our statement can be read as when x equals 4, line U is parallel to line B. Make sure you write that out, okay? Because this is only true when x is equal to 4, all right? So going from that end, if a diagram shows that two lines are parallel, you can use that information to determine angle measures. But if a diagram shows that two angles are congruent, you can use that to prove that the two lines are parallel. So that kind of talks about going from there. So if we look at this next one, all right, what important information can be indicated in each diagram? What can that be used to determine? So in this case, if we look at the left feature here, okay, we are given two parallel lines because of these two figures. All right, so what that can tell us here is, hey, since those two lines are parallel, we can use that information to determine angle measures. So an equation I could set up is, hey, these are corresponding angles. All right, so we're not going to finish this, but the equation I can write is, since those are corresponding angles, I know that these two angles have to be parallel. So I could say 139 plus x equals 130. And I will let you finish the information from there, okay? And then, but the difference is, or what we kind of learned today, is that we're not given that U and V are parallel on the right side. We're just given that these two angles are congruent. So if these two angles are congruent, I can use this to prove that line U and line V are parallel. when I find the value of x that makes that. So in this case, again, the corresponding angle. So I could set this up to 21x minus 6 equals 120. They are similar yet different in each way, all right? Remember, in geometry, no matter what the topic is, I know we've been talking about it, it doesn't matter what you are given, you have to make sure that you use the right information. Every little problem can be different depending on what you're going to be given, and every little problem you are given might be a little different from there. So with that being said, you are going to get some classwork now, and then your homework will be the 3-3. We will go over this homework when I return from my honeymoon. Hopefully you guys are hanging in there. If you have any questions, remember, don't forget to check in with your math coaches in the ELB or any other math teacher. Hope you guys are doing well. Can't wait to get back. See you guys soon. Take care.